प्रोसीजर उसका सही है लेकिन आंसर मैच नहीं कर रहा, तो उसको दूसरा प्रोसीजर से अगर बनाएंगे, मतलब प्रोसीजर सेम रहेगा, बस मेथड अगर दूसरा कर देंगे ना तो
मेथड दूसरा मींस व्हिच मेथड, हाउ टू फाइंड द रैंक?
नहीं, प्रोसीजर दूसरा, मेथड सेम रहेगा, सॉरी उल्टा बोल दिया।
हाँ, सो ठीक है, जो क्वेश्चन एक दे रही हूँ जो इसमें इस रेंज में नहीं है, जस्ट ट्राई टू डू दैट। Oh, this is a 937 sum.
मैम एक और मैम
No, I will not solve the more sums on this range. ऐसे करूँगी तो I cannot start chapter 8. Today is 19th हो गया. How to complete the chapter 8? Tell me. Doubts बोलो।
मैम बस ये पूछ रहे कि मैम आप बोले थे ना कि जब तक जो पी रहेगा और जो इंडिपेंडेंट मतलब जो रैंक निकलेगा वो दोनों जब तक सेम नहीं रहेगा तो वो लीनियर इंडिपेंडेंट नहीं हो सकता है, राइट?
हाँ, यस।
तो मैम आप कल जो फर्स्ट नंबर सॉल्व किए तो उसका रैंक तो अलग निकला था पी से, पी उसका 2
ये
था।
क्वेश्चन
हाँ,
ठीक है, क्वेश्चन 1 का
रैंक 1 निकला था और उसका पी तो 2 है, तो लीनियरली डिपेंडेंट हो जाएगा ना मैम, वो तो इंडिपेंडेंट नहीं होगा।
इसका क्या है, p नंबर ऑफ वेक्टर्स इज 2 एंड रैंक इज 1।
हाँ, तो
हम लोग तो इसमें क्या है, इसमें वी आर नॉट चेकिंग द लिनियरली डिपेंडेंट इंडिपेंडेंट, हम लोग ये कि रैंक निकलना है। और
तो अगर इंडिपेंडेंट नहीं हो तो मैम बेसिस कैसे निकाल सकते हैं? जो इंडिपेंडेंट होता है उसका बेसिस निकलेगा ना, अकॉर्डिंग टू थ्योरम जो आप लिखवाए थे स्टार्टिंग में।
हाँ,
तो मैम इसका बेसिस तो नहीं निकलना चाहिए बट 1 नंबर का, लेकिन पीछे आंसर में बेसिस भी दिया हुआ है।
basis means your basis is that is the number of first we are calculating the rank. Okay, if suppose the rank is 1, so basis contains only one vector. Yes, but as per theorem, yes, agar what if the rank of A is less than P, if rank of A is less than P, then the given set of vectors are linearly dependent. And here, if the rank of A equals to P, the given set of vectors are linearly independent. Yes, but here yes, you are right. But the rank is what is the number of non-zero rows in row echelon form. इस केस में रैंक कितना था क्वेश्चन नंबर 1 में?
1 था, रैंक 1 है भाई।
हाँ 1
क्वेश्चन नंबर, अच्छा इसमें 1 था और रैंक 1 मींस
लिनियरली डिपेंडेंट हो जाएगा।
नंबर, यस
एक्चुअली वो फर्स्ट नंबर का प्रॉब्लम नहीं है, हम 9 7 8 जो भी बनाए ना सब में सेम प्रॉब्लम हो रहा है, सब में यही चीज,
सब में सेम प्रॉब्लम हो रहा है।
हाँ मैम, सबका मतलब लिनियरली डिपेंडेंट आएगा और सब बेसिस भी दिया हुआ है, तो मतलब क्या हुआ है, जब लिनियरली डिपेंडेंट है तो बेसिस नहीं गिवन होना चाहिए ना मैम, बट फिर भी बेसिस निकाल रहा है।
यस, आज पर देखो जो लिनियरली डिपेंडेंट इंडिपेंडेंट अगर पूछा जाए, पूछ रहे तो वी हैव टू यूज दैट थ्योरम। अगर ये बेसिस rank, if the rank is non-zero means definitely it contains the basis the maximum number of linearly independent vectors, either row vectors or column vectors.
इंडिपेंडेंट आएगा ना?
हाँ, इंडिपेंडेंट आएगा, तो ये बाकी केस में नहीं आ रहा है।
नहीं मैम फर्स्ट वाला के जैसे ही सब है, फर्स्ट भी ट्राई कर लिया 9 7 सब में वही आ रहा है, सबसे एक कम आ जा रहा है, रैंक कम आ जा रहा है पी से हमेशा, तो लिनियरली डिपेंडेंट हो रहा है, हर केस लिनियरली डिपेंडेंट हो रहा है, लेकिन बेसिस वही दिया हुआ, जो कम है वो उसी का बेसिस दिया हुआ है।
कॉन्सेप्ट तो नहीं होना चाहिए। तब छोड़ो, इसके ऊपर अगर ज्यादा अभी बाद में डिस्कशन करेंगे, ठीक है? पहले तो एक बात ओवरऑल फिनिश इट। तुम अभी देखो, पहले फर्स्ट यू डू द रैंक, देन बेसिस द नंबर ऑफ वेक्टर्स, देन बाकी जो बात छोड़ दो, ठीक है? अगर linearly dependent independent, you can take in the two methods you can find. I can take through linear combination equate to 0. Through this method you can check, or by using the theorem. The rank of A is less than P, linearly dependent. Rank of A is equal to P, then it is linearly independent. अगर जो क्वेश्चन में देखो अलग अलग टाइप का, सपोज रैंक पूछा है, फाइंड बेसिस मीन्स जो जैसे बताया, जस्ट यू प्रोसीड इट एंड लेट अस सी।
Okay.
Before exam, अगर if I will if I can have time, then I can proceed. I don't know whether I can get the time or not, because chapter 8 again it will take the time. Okay, the rank, just you see the through row echelon form, and then if suppose if the rank is 2, then the basis contains 2 vectors up to this, at least in this way,
Do
just to proceed it.
okay.
Okay,
Okay.
अगर इसको पकड़े रहेंगे ना हम लोग, डेफिनेटली कैन फाइंड मिनिमम 2 to 3 क्वेश्चंस फ्रॉम चैप्टर 8, नहीं तो वो छूट जाएगा.
Okay, ma'am. Okay.
ठीक है. Another part is जो क्वेश्चन दे रही हूँ, that is not in your 10th edition, that is the what, that is your 9th edition. This is from the 9th edition. This is the one of the important question. The same way for row space and for column space. The matrix A is given a 1, 1A, where A is any constant. 1A, 1. We don't know the exact value of A, 1, 1. Okay, so for the same instruction part is find the rank of A basis for row space as well as column space. For row space and column space. Okay, so for row space, then find its what is your देखो A equal to 1 1 A 1 A 1 A 1 1. So now here just you apply. We have to make it, this 2 will be 0. That is your R2 is replaced by R2 minus R1. R3 is replaced by R3 minus AR1. At the 1 1A. This is the 1 minus 0. A minus 1 1 minus A. Is it correct? And this is your 0 1 minus A. 1 1 minus A, that is your 1 minus A square. Okay, so next part is, look at here, this is your A2 is not equal to 0, and we have to make this element 0 with the help of R2. So now here R3 is replaced by what? Simply R3 plus R2, R3 plus R2, at the 1 1 A 0 A minus 1 1 minus A 0 and 0. This is the simplified, that is your what? 2 minus A square. Now we can proceed, because this is your A33 and there is no element below A33. This is your row echelon form. This is your row echelon form. And here, can you find out the rank? The exact value of A is not 1. Just to see, suppose if A is 1, and this last matrix can be reduced to, if A is 1, then this is your 1 1 1 0. A is 1, that is the 0 0 0 0 0. Is it clear? If A is 1, then what is the rank? Rank of it reduces to rank of A is 1. And what is your basis? Basis is the 1 1 1. Okay, and
मतलब
here
exam
suppose, so here suppose if A is 1, then suppose if A equals to what? If A equals to minus 2, then this matrix reduces to, so the rank of this matrix will depend upon the value of A. The rank is different. Suppose if A equal to minus 2, then what is the A? This matrix reduces to, suppose A equal to minus 2. What we are getting? 1 1 minus 2. Next matrix is 0 minus 3 3. A is minus 2. 0 minus 3 3. And next time what? That is your 0, 0. A is minus 2. Minus 2 is 4. 4 minus 4. This is the 0. Is it correct? If A equal to minus 2, then the last matrix reduces to. Then here, what is your rank of A? Rank of A is 2. If A equal to minus 2. And basis you can write down. There are the two linearly independent vectors. So this is your 1, 1 minus 2. And another is 0 minus 3, 3. Okay. And here if suppose if A is neither 1, A is not equal to 1, not equal to 1 and minus 2, then what is the rank of A? Except 1 and minus 2, suppose A is any other value, then what is its rank?
3.
Rank of A is 3 because you cannot get any 0 row. So here, then the rank of A will be 3 and you can find the basis. Okay, so here, so similarly you can find for column space. For column space, now you can find, just to find out the A transpose, then the rank of A transpose, this is your homework. Rank of A transpose, then find the basis.
मैम रैंक ऑफ A3 भी निकालना होगा।
Rank of
रैंक ऑफ एक मतलब जब रैंक ऑफ A3
A
हो
transpose.
हम सोचिए मैम ये सेम क्वेश्चन रहा, हम लोग को बोथ रो स्पेस एंड कॉलम स्पेस दोनों का निकालना पड़ेगा। या फिर
अगर इंस्ट्रक्शन दिया रहेगा, अगर इंस्ट्रक्शन है क्वेश्चन में इन द एग्जाम, बट हियर इट इज एज पर इंस्ट्रक्शन वी आर डूइंग
डू बोथ।
हाँ both, इसमें in the book exercise it is given that by the both space we have to find out. अगर exam if it is not mentioned, then only you have to find the.
मतलब एग्जाम में अगर बोला कि बोथ रो स्पेस
you have to proceed according to the instruction part बस.
ओके मैम, अगर कोई
जो
इंस्ट्रक्शन
instruction
नहीं
दिया
दिया
रहेगा
है
उसे
तो एक बनाने से चलेगा।
हाँ हाँ yes okay. So next part is look at here, look at the vector space. Is the given set of vector space, is the given set of vectors a vector space? If yes, then we can find the dimension and basis. If it is not a vector space, then we can find the dimension and basis. So before this 27 to 35, and look at here, it has the blue shaded means it has the only it has the less importance in the exam part, only definition may come, not so you should not give more time to linear transformation, vector space, basis, linear dependence, independence. Okay, it is. And yellow mark means the question will not I will not cover up the yellow part, but here I have to cover up the Gauss-Jacobi method. Gauss-Jacobi iteration method is included for exam.
हम आप बोले थे नहीं आएगा।
हाँ नहीं आएगा फिर, because later on I came to know that this method I have to cover up. Gauss-Jacobi is very easy than Gauss-Seidel method. So but this part, for this part, so
Will we get commits the three methods or in the exam paper, or we have to?
this page is who is three methods?
Gauss, Jacob, Gauss.
Gauss-Jacobi, Gauss-Seidel, yes.
तीनों करके जाना जरूरी है या एक करके जाने से भी होगा, एक या दो?
और जो छोड़ के जाओगे अगर उससे क्वेश्चन आ गया तो
इसीलिए तो
क्या करोगे? अगर उससे क्वेश्चन आ गया तो सो बेटर देखिए जो मैं क्लास में जो मेथड्स कवर अप कर रही हूँ, ट्राई टू डू दैट. So yes, what is the vector space? And vector space is B is definition of a vector space. Okay. So first V is a non-empty set. It is a vector space. It is denoted by V. Okay, and there are the V. It is should be non-empty. The non-empty set. VJ set, non-empty set, and here there are two binary operations. The two binary operations are defined on V. The two binary operations are defined on V. How to define? So non-empty set, a non-empty set V is said to be a vector space. Is said to be a vector space if it satisfies the first one is a vector addition. If there is defined a vector addition on V, that means suppose here U plus V belongs to V. If U is in V and V is in V, U and V both are two vectors, and if the sum of two vectors is in V, that is called the vector addition. And second point is scalar multiplication. This is one is your scalar multiplication, vector addition on V, scalar multiplication on V. That means your alpha U belongs to V or any scalar alpha and U belongs to V. Any scalar alpha means this relation holds for both alpha. It holds for any scalar alpha means alpha. Yes, alpha is any real. Real means it's satisfied for both positive and negative as well as for zero के लिए. For all scalars it must satisfy. So if any non-empty set we satisfied these two conditions, one is vector addition and scalar multiplication, then we can say that set is a vector space. There are so many other properties, so no need to verify. It is sufficient. Or combining both, we can write down. For both alpha U plus beta V belongs to V, then also V is a vector space. Then V is a vector space. देखो इसमें direct combining both vector addition is there and scalar multiplication is there, where alpha and beta be any scalars. पासवर्ड दूँ. Okay, so then what do you mean by the dimension? Dimension of a vector space is dimension of a vector space. You see the number of vectors in a basis, and number of vectors in a basis, and basis is the maximum number of linearly independent. Basis is the maximum number of linearly independent vectors in a vector space. Dimension, number of vectors in a basis. Basis, maximum number of linearly independent vectors in a vector space V. And vectors is the vector addition and scalar multiplication. These are the vector space. Subspace. Subspace is itself a vector space. Is itself a vector space. with respect to vector addition and scalar multiplication. With respect to vector addition and scalar multiplication. Okay, so now let us come to the exercise. Look at here. The common the example is example of vector space Rn. That is your n. It is itself a vector addition, n-dimensional vector space. N-dimensional vector space. And every vector of Rn must contain n number of components. So suppose let u v belongs to Rn. Rn means u has how many number of components? u1, u2 up to un. N number of components must be there, and v is also v1, v2 up to vn. Okay, or you can write down in the. So when you will add u plus v, or better you write down in the, it gets transpose. Vector addition means u plus v must be in Rn and alpha u must be in Rn. So Rn, the standard vector space must be a vector space. How to verify? Through the exercise you can verify. Suppose look at here, question we have to look. Suppose question number 29. Question number 29. All vectors in R square with v1 is greater than equal to v2. So here, if one of the condition does not satisfy, then you cannot say that it is a vector space. So question number 29. लिखा है all vectors in R square with v1 is greater than equals to v2. All vectors in R square with v1 greater than equals to v2. Okay, so first look at it. R2 means every vector in R2. Am I audible?
Yes, ma'am, you are audible.
Yes, ma'am.
In R2, every vector must have the two components. First, we have to write down in the set form. How to write down? This is your, look at here, R2. This is your U belongs to U equals to, just I'm writing that U1, U2. Oh, sorry, V1 with V2. So better first we have to take V. So this is your V1, V2. So that R2 means two components, and it is given that V1 is greater than equals to V2. Okay. So and here this is R2. We have to verify. To verify R2, that means our V here, V equals to R2, is a vector space or not? Is a vector space or not? Okay. Let U comma V belongs to R2. Then U has maximum how many number of components? U1 two components, and V has also two components, V1, V2. So what is your, look at here, and U belongs to R2 means definitely U1, U has two components, not more than that. Along with the first component must be greater than equal to second component, because it is given that by this instruction. But any vector of R2 must have two components with first component must be greater than equal to second component. Similarly, V belongs to R2. V belongs to R2 means V has two components, V1, V2 with first component is greater than equal to second component. V1 is greater than equals to V2. All are clear? And what about what about U1, U2? All are the real numbers. U1 belongs to R, U2 is also R. U1 has two components, all the components are real. V1 similarly, V1 is real, V2 is also real. Is it clear? Up to this? Up to this, is it clear?
मैम एक्चुअली क्या करना है वो समझ में नहीं आ रहा।
क्या करना है? अभी मैंने जितना जो लिखा है, जितना लिखा है वो समझ में आ रहा है?
Yes, ma'am.
R2 देखो, R2 मतलब ये स्टेटमेंट है, all vectors in R2 with first component must be greater than equal to second component. Whatever the vectors in R2, in each and every vector, first component it is obey. It is obey that first component must be greater than equal to second component. Okay. So here suppose U and R2 is defined by let V, and here V belongs to R2 where V1, V means it has two components and V1 greater than equal to V2. And what about V1, V2? Both are real. Similarly, if U belongs to R2 means the same way U has two components U1, U2 where U1 is greater than equals to U2. Similarly, V1, V2, we have to verify V is a vector space means first we have to do the vector addition. Vector addition is we have to verify that U plus V belongs to R2. It is vector addition is question mark whether it is in R2 or not. Okay, how to verify? What is the U plus V? Is U1 comma U2, V is V1 comma V2. What about U plus V? Component wise we can add, that is your U1 comma U2 plus V1 comma V2, and you add component wise. This is your what? U1 plus U2 comma V1 plus V2. Is it clear? But समझ पा रहे? Component wise simply I have added. And look first, देखो, if U1 is real number and U2 is real number, what about U1 plus U2? If U1 is a real number, U2 is a real number, then obviously sum of two real numbers is again a real number. So U1 plus U2 is also in a real number. Similarly, whether V1 plus V2 is a real number or not. If V1 is a real number and V2 is another real number, then what about V1 plus V2? The sum of two real numbers is again a real number, so V1 plus V2 is a real number. Okay. And another way the given but. So again we have to verify U plus V belongs to R2 means one part is satisfied. U plus V, U1 plus U2 is a real number, V1 plus V2 is a real number. And what is your first component? Here this is your first component. First component. And what about this part? This is your second component. This is your second component. And here Your what is the instruction part? First component must be greater than equal to second component. That means if you can show that
मैम ये ऐड कैसे किया है?
component wise add किया.
मैम तो u1 प्लस v1 क्यों नहीं हुआ?
मैंने एडिशन में गलत किया क्या?
नहीं मैम, वो मैं वैसे मतलब कुछ और
हाँ
सोच
हाँ,
रहा
राइट
था
राइट
मैं।
राइट, यस यस, u1 u2, oh sorry, yes you are right.
ओह ओके मैम।
For component is we have to evert. This is u1 plus v1, yes, u1 plus v1, another u2 plus v2, yes. Component wise we have to add. So this is your so u1 plus v1 is also a real number. Is it clear this part? So now here what is your first component? Again we have to show that. To show that what is your first component? If you can show that u1 plus v1 is greater than equal to u2 plus v2, is it greater than or equal to? Whether it is, how to prove that it is greater than equal to? Greater than equal to, we can say v1 is greater than equal to v2. Then what is your first component? u1 plus v1 must be greater than equal to u2 plus v2. Now here हम लोग पास इतना पता है. Now it is given that uv belongs to r square. This implies u1 is greater than equals to what? u2 and v1 is greater than equals to v2. Then ये दोनों को both side add करो. From this part, just left hand side, then u1 plus v1. So the proof is done. Okay. So that means look at here, u1 plus v1 both are real number, u2 plus v2 is also a real number, and the first component is greater than equal to second component. That means your vector addition is satisfied. Vector addition is satisfied by R2. We have to cross check the scalar multiplication. For scalar multiplication, what is your scalar multiplication? That means, look at here, let alpha is any real number and u belongs to R2. Here we have to show that. We have to show that alpha u belongs to R square. Okay. And look what is the given that. Given that given that, what is your given part? v1 is greater than equals to v2, or we can write on u1 is also greater than equals to u2. u1 is greater than equals to u2. Okay. And just you alpha, you multiply alpha on both sides. Then it is alpha 1 is greater than equals to alpha u2. And suppose if you take alpha is minus 1, does this relation hold? For alpha, this it is holds. For alpha equal to 0, alpha 0 means equality आ जाएगा. If alpha is positive, then this relation holds. But when alpha is negative, when alpha is negative,
मैम तो रिवर्स हो जाता है.
reverse हो जाएगा. That means minus u1 is greater than or equal to minus u2, but there is no less than sign. There is no less than sign. That means we cannot say that this relation holds for all alpha. What is the conclusion? But when alpha is negative, it does not satisfy this condition. So the conclusion part is alpha u cannot be in R2 for all alpha. So since the second condition it does not satisfy, the conclusion part is hence R square is not a vector space. Is not a vector space. If R square is not a vector space, then no need to find basis and dimension. No need to find basis and dimension. If it is a vector space, then you can find basis and dimension. Now we are minimizing. There I think lots of doubts are there because all are silent, and just to go through it. All have to go through it. How to vector addition means vector space means we have to verify the two properties. One is vector addition, another is scalar multiplication. So how to do it? Can I scroll down?
Yes, ma'am.
Just to see.
Very good. Thank you. Thank you.
मामा पढ़ेगा नहीं? So, is it clear why it is not a vector space? Tinta. Some second half exam date.
Last.
Second or first exam date. Right. So, we have 7 minutes left. Still, I could not complete. Is it all are clear why it is not a vector space?
Ma'am, please explain again why it is not a vector space.
तो जो कौन से स्टेप एंड डाउट से तो बताओ. वेक्टर टू बी वेक्टर स्पेस we have to verify two properties. One is vector addition, another is scalar multiplication. Vectors addition पर देखो R2. Now R2 is any vector. Suppose let V belongs to R2. Because your power is 2 means it has two components V1 V2. With the condition is it is given in the statement. So first component must be greater than equal to second component. V1 is greater than equal to V2. Okay. So let U and V in R2. That means U must have two components, V must have two components. Where what about U1, U2? Both are two real numbers. Two components are the real numbers. So U1, V2 is also the two real numbers. So look at here. U has two components U1, U2, and U1 is greater than equal to U2. V has two components V1, V2, and V1 is greater than equal to V2. Up to this, is it clear?
Yes, ma'am. Yes, ma'am, it's clear. But ma'am, ये जो V1 greater than V2 है, ये सब में दिया हुआ है या ये हमारा?
Yes. Question number 29. All vectors in R2 with V1 greater than equal to V2. ये दिया हुआ है।
Okay.
जो भी वेक्टर R2 में होगा डेफिनेटली ये कंडीशन सेटिस्फाई करेगा। फर्स्ट कंपोनेंट्स मस्ट बी ग्रेटर देन इक्वल टू सेकंड कंपोनेंट्स। क्लियर?
Yes, ma'am.
So another part is another part is look at here, that is your yes. Just you add the u plus v, u1 comma u2 plus v1 comma v2. So after adding u1 plus v1 comma u2 plus v2, this is our first component, this is second component. So look at here, if u1 is a real number, v1 is a real number. Just wait. Look at here. Okay. So here, so a1 v1 a2 v2. Okay. If there e1 plus v1 is real number because e1 is real, v1 is real. So here sum of two real numbers is again a real number. So next part is u2 v2. u2 is a real number, v2 is a real number. So u2 plus v2 is a real number. Then next part we have to show that the first component is better than equal to second component or not. देखो, u belongs to R2. u1 is greater than equal to u2. b belongs to R2. So obviously, so this is the v2. 1 is greater than equal to v2. So obviously, u1 plus v1 must be greater than equal to u2 plus v2. So vector addition is satisfied. Okay. And what about the scalar multiplication? The scalar multiplication is, like what we have to show that alpha u must be in R2 for all alpha. For all alpha means what? This condition is satisfied when alpha is 0, when alpha is positive, when alpha is negative. But for negative case, it does not satisfy. So u1 greater than equal to u2 and just multiply alpha. Alpha means alpha u1 should have greater than equal to alpha u2. But this relation when alpha is 0. 0 means what? Equally condition RI. Alpha positive means E satisfy over I. But when alpha is negative, just for alpha is -1. So minus u1 greater than equal to minus u2. Negative less than or equal to RI. So what less than sign, it is not in the set. It is not in the set. Only either greater than or equal to. So this implies, hence, since for negative case this relation does not hold, so it is not a vector space. Because to be a vector space, simultaneously both vector addition and scalar multiplication must be satisfied. So since one condition is not satisfied, so it is not a vector space. So since R2 is not a vector space, we cannot find the basis and dimension. So next class we have to solve another sum which is vector space and how to find its basis and dimension.
Okay, ma'am.
So here then again I'm calling the absent roll numbers.
नहीं मैं से कोई और
अभिजीत
मैथ्स का कोई और असाइनमेंट बाकी है मैम या फिर हो गया?
नहीं, सेकंड असाइनमेंट तो तुम लोग सबमिट कर देना।
हाँ
हाँ, नहीं और असाइनमेंट कहाँ है, टाइम से असाइनमेंट और मिलेगा।
क्विज भी नहीं है ना?
क्विज भी नहीं है।
ओके
लुक एट रोल नंबर 59, 67, then 69.
Yes, ma'am. Ma'am, 75
टाइम
present.
से जस्ट वेट।
मैम आपने बोला था जिनका क्विज छूट गया है उनका वाइवा लेंगे या असाइनमेंट देंगे?
नहीं, वाइवा और दोबारा क्विज अभी तो हाँ मैं इन्फॉर्म करूंगी, ठीक है। how many of them are defaulters?
मेरा मूड वाला प्रॉब्लम अभी तक ठीक नहीं हुआ।
हाँ 69 प्रेजेंट। अभी तो और
Yes,
एक बार
ma'am.
मेल करो, मैं उसमें उस दिन तो मैंने फॉरवर्ड किया था। 75
Present, ma'am.
अभी रिपीट विट से एग्जाम ड्यूटी चल रहा है यार। 116 116 ओके। Okay, thank you all for joining this class. Tomorrow you don't have class, right? Day after Friday, I will finish the chapter, 7.4, 7.9, just one definition. Then I will start chapter 8.1.
मैम जो ब्लू किए हुए हैं, लाइक 7.4 ब्लू किया हुआ है और कुछ टॉपिक्स ब्लू किए हुए हैं, उसके
और तो
क्वेश्चन
कुछ ब्लू, अरे ब्लू तो वाला बस इतना ही है ना, लीनियर ट्रांसलेशन वेक्टर्स पे बेसिस, बस ये जो ब्लू वाला है। हाँ, इससे हो सकता है डेफिनेशन वगैरह आ सकता है, बट यू शुड नॉट गिव द जो व्हाइट वाला है वो ज्यादा इम्पोर्टेंस है, जो ब्लू वाला है वो लेस इम्पोर्टेंस है, जो येलो वाला है उसको कवर अप नहीं करेंगे।
मैम मतलब मैथ्स एकदम नहीं आएंगे मैम उससे, ब्लू वाले से सिर्फ डेफिनेशन
आ
वाले।
सकता है, सब बहुत छोटा क्वेश्चन भी आ सकता है, नहीं तो छोटा मोटा डेफिनेशन भी आ सकते हैं। पूरा नहीं आएगा ये आई कैन नॉट से, आ सकता है बट
ऑरेंज वाला
ये
करेंगे।
ऑरेंज नहीं, ये एक्चुअली व्हाइट होना चाहिए, गलती से ऑरेंज हो गया। इसको तो हम लोग डिस्कशन करेंगे, आई विल डिस्कस ऑन फ्राइडे गॉस जैकोबी। इट इज वेरी सिमिलर विथ गॉस सिडल, ठीक है। ये होने के बाद चैप्टर 7 पूरा कंप्लीट होगा। लिनियर ट्रांसफर बस एक ही डेफिनेशन एंड वन एग्जांपल आई विल गिव ऑन। लो देखो 8.1 पूरा पढ़ना है। 8.1 पूरा डिस्कशन करेंगे। 8.35 इंटरलिंक, 8.3 रियल मैट्रिक्स, 8.5 कॉम्प्लेक्स मैट्रिक्स। तो 8.35 एंड 35 8.4 का डायगोनलाइजेशन है, क्वाड्रेटिक फॉर्म ये है, बट सिमिलरिटी मैट्रिक्स नहीं है।
हम यहाँ पे असाइनमेंट ही दिखा रहा है जो क्रिटिकल थिंकिंग है, बट वो योलो नहीं किया गया है। हम क्या आएगा
ये वाला, ये और तुम लोग को अभी असाइनमेंट नहीं मिलेगा अभी तक तो नहीं ना, और 10-11 तुम्हारा ये ना 2 फरवरी से स्टार्ट है।
मैम 24 से सही बोलेंगे तो केमिस्ट्री प्रैक्टिकल लैब।
अच्छा लैब, हाँ प्रैक्टिकल एग्जाम तो हमेशा पहले होता है, उसके बाद थ्योरी पेपर्स होता है
नेक्स्ट वीक से।
नेक्स्ट वीक से। अच्छा, बट आई डोंट नो, बट एनी तो वी हैव टू कवर, एक बार कवर हो जाएगा देन वी कैन डिस्कस आफ्टर दैट डाउट्स कि अगर कुछ। बट एनी पूरा एकदम न्यू है। 8.1, 8.35, then after that 8.4 का वन पार्ट नहीं है बट अदर 2 पार्ट्स है। व्हाट मीन बाय डायगोनलाइजेशन, क्वाड्रेटिक फॉर्म क्या है, ट्रांसफॉर्मेशन क्वाड्रेटिक फॉर्म टू प्रिंसिपल एक्सिस, ये सब कवर अप करना है। ओके, मैं फ्राइडे क्लास लेने के बाद सैटरडे भी, अच्छा सैटरडे में तुम लोग का 2 क्लास है ना, देखूंगा और एक ही क्लास एक्स्ट्रा क्लास हो पाएगी नहीं, चेक करके बता दूंगा, ठीक है।
मतलब कब होगा?
सैटरडे पूरा इस महीने तो पूरा सैटरडे तुम्हारे इस बार फ्राइडे का टाइम टेबल रिपीट होगा।
अच्छा,
फ्राइडे तो ऑलरेडी तुम्हारा 2 क्लास है, सैटरडे भी 2 क्लास है, तो देखते हैं, ठीक है।
यस मैम।
ओके, सो नेक्स्ट क्लास मिलेंगे। ओके, बाय बाय।
Bye, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.